Hi, in this episode I would like to give you a short introduction to it.The, the text editor of SOFiSTiK, and to the CADINP language. I already created this video a while ago, so the sound quality might not be the best. Sorry for that, but I think the most important information about the topic will be able to go through to you. In the next chapter I'm going to introduce to you the CADINP language and it.The, the text editor of SOFiSTiK. First, you need to start it.The 2020. You can either find it on your desktop or you can go to the Start menu, Windows Start menu, and type in it.The 2020, click on it, and then it will be open up for you. it.The is not just simply a text editor for our CADINP language, but it's also a program control center like the SSD for the graphical tasks. This means that you can communicate between the program modules and also the programs of SOFiSTiK from it.The. This means when you have a project open, you can also go to the system visualization or to the graphics, open up the result viewer or the report browser. You can undertake a calculation on all of the modules or just some of them. And you can even work with graphical tasks if you want to. Now let's have a closer look at the different sections of the text editor. We can find a normal menu bar like in any other Windows application, but also you will find here some calculation related commands. You can also verify the calculation reports. You can undo a command or redo a command. From version 2020, the navigation in the text editor switched to the ribbons entirely. You will find the File, the Home, Edit, Insert, View, and Help ribbon bars. If you right-click anywhere on the ribbon bar, you have the possibility to minimize the ribbon by choosing this checkbox, and it makes you extra space for editing your text. And whenever you click back the ribbon, it's going to be open up entirely again. But then if you click away, then again you have the extra space for editing. Now let's have a closer look at the File menu. Here, of course, you can create a new document or open up an already existing document. But what I would like to point out is the examples entry. This command brings you straight to the available it.The example files that are stored in the installation folder. These files are available almost all of the program modules and describe the input of different topics. So if you click on it, for example, then you will be directed to this example folder, and you can search for an example file based upon the name of the module. For example, if I want to see an example file regarding module ASE, then I open the folder ASE, go to the English examples, and here, with double-clicking on any dot file, the example file will be open for me. Reviewing and using these example files together with the manuals of the modules is the best way of learning the possibilities within one specific module. But now I would like to talk a little bit more about the context and the syntax of the CADINP language. Therefore, please simply close back the example file. Also close back this already open example by clicking on the X in the top right corner. Do not save it. And let us create a new it.The file. First, I would like you to go to the File menu and click on the New sub-entry, and the new empty it.The file will be open for you. First, you need to save this newly opened file by clicking on the diskette icon or pushing the Ctrl+S keyboard combination on your keyboard. If you do so, then you need to specify a location on your hard drive to store this data. Please go to your desktop BTC Bridge folder, and here create a new folder called it.The. Enter into this folder and add the name example 1 and then click on the Save button. Please notice as soon as we save the file, the project name .dot file has been created in the PTC Bridge TEDI folder. And now we are ready to start to write our first TEDI input. To activate a module in TEDI, you need to start your input with a plus prog command and then the name of the module. For example, I will type in aqua, which module stands for the definition of the material and the cross sections. Then in the forthcoming line, you need to enter head, and in the following or the next command line, you need to enter end. With the head and the end command helps the software to understand where the input starts and where the input ends in the specific module. In between the head and the end lines, you can create more lines by hitting the enter many times. It is possible to enter commands either in English or in German. The software will automatically recognize in which language you are working from the head and the end commands. For example, in this case, the software will know that we are working in English. However, if I change the input head to Kopf and the end command to Ende, then the software will know that the inputs in between will be in German. As you can see on the screen now, the commands are with dark blue color. The name of the modules are presented with red. After the head command, you can also define a heading that will be printed in the report browser of this module. For example, I will enter here definition of the materials and the cross sections. The location of the cursor is always shown for you live. In the top line, it is presented that currently the cursor is blinking in line 2 of 7, and the position within this line is at column 9. So this is the 9th column or position 9. Now I'm going to enter some input in this module to be able to explain the syntax of the commands. After having entered some lines of input, now we can discuss how the commands, the items, and the values are presented in TEDI. As I mentioned previously, the commands are presented with dark blue color and they are maximum 4 characters long. Then next to the commands you can see the items with light blue colors. A command can have many items, but the same rule is applicable for the items as well. Namely, the length of an item can be maximum 4 characters. After the items, you must enter a value which is presented with black color. The possible input for a value can be a number or a letter, or even it could be a text. Or sometimes we refer to the text input as string input. If your cursor is blinking in a line and you push the F1 button on your keyboard, then the online help, the online manual of the current module will be loaded. The online help is an interactive PDF. You can make the view of the online help a little bit bigger to be able to read the command description and the item description. Now in the online help we can see that we are at command norm, and we can also see the available items for this command, for example DC, NDC, count, cat, and so on. In the next column you can see a small description about the item. Then you will find the unit that the TEDI expects from us to enter. And then you can see the default value for this item. Sometimes the unit can be a literal, but sometimes it's a real unit. If you do not know what the command does, or just general description is necessary for you, please scroll down always the online help, because below the input table you will always find explanation about the command. It is always very useful to read the chapter name, the corresponding chapter name of the command, because normally it gives you a very good idea what this command does. For example, the norm command creates default design code for our project. The corresponding graphical input was when we set up the code in the system information dialog box graphically. Similarly, if I now click on the conc command, for example, and read the title, I can see that most probably I'm defining a concrete material here, and I can specify the properties of this concrete material. At this point, it's worth mentioning that you can also find another online help. If we look at the very bottom line of the TED window, then we will also find the structure of the particular command. Here, the first entry, always the command name, and then comes the forthcoming items, for example, NO, type, FCN, FC, and so on and so forth. So a valid command line always consists of the command name, the items, and the values right after it. If you follow the predefined order of the items, basically you can simply leave them out and only adding the values corresponding to the items. But this can be only done when you follow the given order of the items next to the command. As soon as you change the order of the items, for example like this, then you must keep the name of the items, otherwise the software will not know which value belongs to which item. Now, as you can see on the screen, with this movement of the item name and the value, I have created more than one space between the command and the item. This is not a problem. More than one space is allowed. However, one space must be entered, otherwise the software will not recognize the command name or the item name. It is also a very important rule that one item can be defined only once in one command line. This means that, for example, in this command concrete, conc, if I add number 1, so I would like to define a concrete material with number 1, I'm going to receive an error message when I run this module, because I have already defined this on the second position. Because although the item name here is not given, the software will know that after the command conc, the first item and the corresponding value will come, and the first item is the number and then a value of 1. So if I don't write out the item name, just simply the value for it, then the software will understand this value 1 as the item number. Therefore, if I add once more number 1 in this line, I'm going to receive an error message. So I will delete back this errorness input, and I would like to call your attention to another very important rule, namely when you change the order of the items. For example, in this line we can see that the number is after the classification, although the number should be the first item after the command. Anyway, I changed the order, which is fine. But now I need to be aware of the fact that after a valid input for option NO, the software will expect a new input for item type. And if I enter a value being equal with 2, for example, then I'm going to get an error message, since the software expects to add a value for item type. However, the valid input for item type is a text input. Another important rule for the syntax is that in one command line, there can be only 255 characters. If your input is longer than 255 characters, then you need to enter a double $sign and then continue the input in the next line. So the double $sign basically tells the software that the command steal is going to be continued in the next line. On the other hand, if you just use $sign at the end of the line, then you can add a comment to this line. For example, now after the $sign, I will add my comment, definition of the steel material. And this is going to be just an internally comment for you for the future to remind yourself what had been defined in this particular line. There are multiple options in TEDi to create a comment. For example, you can also use the exclamation mark, and then you just simply need to enter your new comment, such as this is also a or you can also use the double dash symbol for a comment. Or you can also use the double slash sign to define a comment. Between the command lines or the comment lines, you can have as many free lines as you want to. After an empty line, TEDi will know there will be a new command starting. Now I'd like to talk a little bit more about the units. Our program allows input and output in the most suitable engineering units. In the background, in the database, the units are expressed in SI units such as kilonewton, meter, and secondum. However, other units can also be used for input and output, such as newton, millimeter, or centimeter square. The users can even change the number of decimals in the input or the output. So let's have a closer look at command norm. Here you will find there is an available item, G, for defining the gravity acceleration. Here we can see the unit is required meter per secondum square. If you simply see a unit without brackets or explanation, then this unit is called a fixed unit. This means that it is always required in the specified unit and you cannot change it. However, if we look at another input line, for example, the command conc, you will find some units in brackets. If you can see brackets without this subscription, then it means an explicit unit input. In case of an explicit unit, alternatively, an explicit assignment of a related unit is possible, such as in this case, for example, kilonewton per square meter. If you see this small green subscription next to the brackets, it means it is an implicit unit. Implicit units are categorized semantically and denoted by a corresponding identity number shown in green. The default unit for each category is design code specific. Another important information is that the command name and the item names can be given in lower or uppercase. It doesn't really matter which one you are using. They can be also interchangeable. So for example, I can start with uppercase and then I can continue with the item names within lowercase. You can duplicate a command line if you hit the F8 button, and as many times as you hit it, a copy of the command line will be created. Also, if you want to deactivate more command lines, you simply select them and with the Alt-C keyboard combination, you can turn them into a command line. Now I would like you to click on the escape button to get out of the online PDF help and click on this icon here, which is going to open up this toolbar on the left side. Here you will find that we are in the example1.dot file and we can activate or deactivate a certain module. When you activate a module and you can see the plus sign next to the prog command, then it means when you perform an analysis, this module is going to be triggered, or this module is going to be calculated. If you have many modules, then you can turn them on and off with the plus and minus sign, and only the modules with the plus sign will be calculated. This time, let's simply run this Aqua module by clicking on this icon at the top line, or we can also call this command off with the Ctrl F12. But now I'm just going to simply click. The analysis was undertaken, but it was so quick that we couldn't even see that. And now I would like to go to the top toolbar and click on the Show Calculation Reports button. And then the report browser will be open for us. And now it could be familiar to you because we already looked at the report browser previously. And here we can see the input of the module Aqua, what we just generated. By default in the report browser, the input description is not shown. However, you can change its behavior if you simply click and open up this chapter or this book chapter here. However, you can change this behavior if you simply click on this book icon and open up the chapter. And now our input made in TEDi will be visible for us as well. If we switch back to TEDi, now we are going to see URS colon 1 next to the prog aqua command. This gray text means that the output of the module Aqua is going to be created in the report browser with the chapter number 1. I will enter now some more input to discuss more possibilities within TEDi. For example, with the exclamation mark, asterisk and exclamation mark symbol, you can define a chapter in your input. A chapter helps you to better orient it in the input. Sometimes you have a very long code in TEDi and you get lost. What are you doing at the moment? In this case, bookmarks could be a good reminder for you. What are you up to in the lines below? Now let me go back to the functionality of the module bar. So the module bar can be seen on the left side. And as I mentioned, here you have the possibility to turn on or off all the modules. Or you can also turn the modules one by one on. Or you can select a module and then you say, please deselect everything from the cursor position. Or in the other way, you select the very last module and you choose, please select all of them up to the cursor position. And after having selected all the modules that you wanted, you simply perform the analysis or clicking on the Ctrl F12 button. If you do so, the analysis will be performed, but it was so quick again that I was not able to show you. However, if we now go to the Home and go to the System Visualization, we can see our system that was generated with a TEDi input, and we can also see the calculated load cases. If we go back now to TEDi, I would like to continue my explanation with the variables. So I have just entered two template modules, and I'm going to talk about the let variable, the store variable, and the define variable. With the help of text input, we can create within or without a module variables with which we can work in the commands, for example, or to use them in our expressions. We distinguish between two different types of variables, the let variable and the store variable. The let variables are valid within the module or block and are saved temporarily only in the module. Whereas the store variables are valid within as well as outside the module or block, and they are global variables and they are saved in the database. So it means that the definition of a store variable will be available when the current block is ended. However, the software doesn't know anything about a variable that was defined with the let command when the current block or module is ended. The defined values of the variables can be printed in the module with the help of command PRT, and they will be presented in the result viewer when the module has been run. It is very important to notice that both types of variables are characterized by the hash prefix followed by the name of the variable. The variable name can be maximum 16 characters long, and the first character must be a letter. It cannot be a number. The name of the variables mustn't contain special characters or collide with a wizard sequence of characters such as sinus, cosinus, square root, and so on. For more information about the already reserved variable names, please refer to the TEDdy manual, which can be found in the Help menu and CADINP Help. And here, for example, you will find yourself right away at the description of the let and stow variables. It is also possible to define a string variable with the command #define. After the #define, you can add the variable name, which can consist of maximum 10 characters, and the first character must be a letter. And later on, this variable can be used by using the syntax $ and brackets, and in between the brackets, the variable name. Let me demonstrate it for you. So here I'm going to add, for example, variable name, and the text input of this variable will be ABCD. And then in the next line, I'm just going to simply print this out in the report browser with the command TXE, and the syntax is $, then variable name, and then a bracket. And if I now run this template module particularly only by right-clicking on it and choosing the execute template and go to the report browser, now I will be able to see the output of this template module. And as you can see, we can see the value of A1 being equal with 1, as it was in the input, A2, which was defined with the stow variable, and the value is 5.23 as it was defined. And I can also read the value of the string variable being equal with ABCD. So basically, you can define a string variable or text variable with the #define command. And if you did it, then you can refer to this variable with a $sign and in brackets the variable name. Also, it is important to mention that the #define command doesn't necessarily need to be given within a module. It could be entered or given outside the module as well. Okay, now let's continue with the explanation of the loops, since it is a command that we oftentimes use in our input. The record loop initiates loops and terminates by the record end loop, as you can see here in this little example. A loop is executed as many times as determined by a number after the loop. You can also terminate the loop if you add an expression after the end loop command, and this expression becomes 0 or negative. So you can imagine something like this. You have an expression, and when the value of the expression is going to be 0 or negative, then the loop will be terminated. It is also worth mentioning that in this particular example file, the loop will be executed 5 times. However, the starting value of variable I will be equal with 0. So the value of variable A4 will be at the beginning 11 plus 0, then 11 plus 1 plus 2 plus 3 plus 4, and then the 5 execution is ended. But let's check as the output of the current module template. After having run the template module, we can really see that the first value of the loop is 11 plus 0 equals 11, then 12, 13, 14, 15. Another useful feature I would like to show you is how to define a multi-line text. Basically, in any kind of module, you have the possibility to insert a multi-line text, which will be presented in the report browser. The syntax of this input is the following. Between the smaller and greater sign, you need to type in text, then enter the string that you would like to present in the report browser, and finally end it with the, again, smaller and greater signs, and in between the backslash text. If you run this module and go to the report browser, you will find the text that you had input. Okay, this concludes the introduction to TEDdy and the CADINP language. All right, thank you for your attention. If you would like to see more advanced techniques in TEDdy in the CADINP language, then please head over to the official SOFiSTiK website, where my colleague Mr. Jürgen Bellmann created 3 advanced videos about TEDdy. I will enter the description to these videos in the text box below, and I hope you will watch them and enjoy them. If you like the content of this video, do not forget to give a thumbs up. That will motivate me to create the next one for you. But for now, bye bye.